Okay, so it started recording. All right. Okay, so this week we just finished discussion on OpenMP programming as such. We started only in yesterday's class. We started the numerical methods for OpenMP. So this tutorial, which was posted yesterday, has 3 questions. Essentially, the first 2 are very straightforward. The first one is develop an OpenMP program to add 2 square matrices A and B of size each of size n by n that contain floating point values. So essentially, you're supposed to fill in some values for A and B, and then maybe you can write an automated kind of a loop or something, and then test this program of addition for this thread count, that is 2, 4, and 8. For the size of the matrices to be for 50 as well as for 100. Okay, so you would consider 50 by 50 matrix and then 100 by 100 matrix. I hope that will kind of give you some speed up that you can see, in terms of the performance. So then I want you to also do kind of time your program using the the timing routines that we have learned, right, in the last week's lecture, and then I want you to kind of see notice if you see any performance improvement. Okay, so that's the first question. I don't know whether you will actually see some performance improvement, but I thought that will be one simple problem to start with. Then, as discussed in the lecture, I want you to also extend this program for multiplication of 2 matrices. Okay, that is also very straightforward. Essentially, you have 3 for loops. Then you can just use the same values that you have filled. So please don't use zeros here. Rather, fill some values, either using some trigonometric functions or or some random number generator or something like that. And then you can also make use of some floating point numbers instead of integers, so that will kind of increase the computation time. And then for this also, I wanted to time your program and see whether you would get any improvement in time. And then essentially, you can run it for maybe one particular size, maybe n equal to 100 or something, or n equal to 150, and then for these number of threads. Okay, so that is the second problem. So these 2 are very straightforward. Certainly, if you want to debug, don't start with 50 or 100. Start with maybe 4 by 4 or 3 by 3, and then you can run with a couple of threads, or 4 by 4 with a couple of threads, and then test it. Once it starts running, then you can go for a large number of size of the matrix and the number of threads. Okay, that I hope you will do. In case you have difficulties, please feel free to write back on the discussion forum, or we can the TAs or we will help you with if you have any issues with that. Okay, all right. And then the third question is basically about calculation of finite differences using explicit finite difference schemes. So basically, one particular function is given, that is 7 minus x tan x. That's basically u as a function of x. This is similar solutions. Similar problems are obtained in the solution of transient heat conduction in a plane wall. And then the length of the domain is given, that is -1 to 1. So the length is 2. Okay. Then I want you to write an OpenMP program to compute the first derivative of u of x, that is du dx, over the range of x given, using first, second, and third order and fourth order accurate central difference formulae. This I have listed yesterday in the lecture notes. Okay, or you can even pick them up from any book on numerical analysis. Okay, so essentially, as you know, as we keep increasing the order of accuracy, the number of terms that we need to include compared to the where we want to calculate would also increase. Essentially, the length of the stencil size also will increase as we keep increasing the order of accuracy. Okay, and then because of that, you may end up basically requiring, let's say, if you are on a boundary point or on a near boundary point, let's say this is your boundary, then depending on the stencil you would use, you may require points. If it is, let's say, second order central scheme, I think you don't have a first order central scheme as well. Right, because the central difference scheme is already second order. So you can use for first order, you can use the forward difference. Okay, and then for the second order, you can use if you have to use the central scheme, then what you have is you would need points on both sides. So which this point doesn't actually exist. So either you can use forward difference for the near boundary and the boundary points, or for this problem, because anyway the analytical function is kind of given, you can even use these points without reducing the order of accuracy. So either method is fine. Whatever suits, you can apply that. And then the grid sizes are given. Basically, delta x is given to be 0.01 and 0.001. Okay, so that is you can calculate the number of points from L upon delta x. Okay, that will be your array length. Then essentially, we want you to test your code for a similar number of processes, 2, 4, and 8 cores. Then compare the results you obtained using the analytical solution. You can of course calculate the what is du dx, and then you compare with that. You can make a graph or table or something like that, and then make sure that the numerical solution you get is kind of correct. Okay, because you may get some solution, but we don't know whether it is correct or not. So you have to kind of check that by comparing with analytical as well as with the serial code that you have. Okay. So these are the 3 problems. I think the first 2 are very straightforward. You can do in no time, because the programs are also shared in the first week of the course. Only the third one is also, I think it's not too difficult. You can probably do it very quickly. Yeah. Okay. So those are the 3 problems. Let us see if anybody has. We can take some questions. Are you guys able to kind of work on the previous tutorials 1, 2, 3, and finish them? Yes. Okay. Good to know that. In case you did not finish, please write to us that you did not finish, or if you have a question. We have 5 TAs, so they can definitely help you. Okay, and we are also there to help you in case you are stuck with something. Okay, you can post it on the forum, so either we or the TAs will pick it up, and in fact the other students will also help you. So the forum will be much more active then. Okay.
Hello. Sir, I have a question.
Sure.
Yeah. So in the last tutorial, there was a question on using the reduction operator for the reduction clause for the subtraction operator.
Right.
So and you asked if there was any you said that it cannot be performed with the subtraction and division, but it can only be performed with addition and multiplication. But I actually found no issue with subtraction. So is there some type of caveat that?
No, I think essentially OpenMP seems to be working even for subtraction. Only thing is that it is not guaranteed to work. So that is the only thing. So for subtraction, essentially, as you know, if you kind of start dividing into chunks, then what happens is you would get some subtracted values here between certain points, certain values, and then some more subtracted here. Then eventually these 2 have to be added because they are working on different processes. They should not be subtracted here. So if OpenMP is doing that, I think that is well and good. But the standard doesn't guarantee that. That's what the standard says. But when you do the division, one problem could be that the floating point division is also not associative, not commutative. So as a result, you make some change in the decimal places. It will not be exactly the same between the 2 operations, but you would get some change in the in the decimal places. Within tolerance, I think it is okay.
Right. Okay. Yeah. Thanks.
Yeah. So at some point, let's say if I ask you to kind of upload the programs that you have written to Moodle or something, you'll be able to do that, right? Just for the sake of completing. They will not be graded, but just for for the sake of the record. Let's see. Some people might be writing in the chat box. Okay, fine. So OMP's WTime does not have good resolution. clock can still be used in the slave threads, right? I don't know. I didn't test it. Maybe if you have tested, you can tell me. So what is the resolution that the OpenMP provides? Is it too large compared to clock? Okay. Maybe Rupesh, can you add something if you know something about this OpenMP's W time and the clock?
Yeah, if this is not working, maybe one possibility might be to use get time of day function, which is provided in the standard library.
Right.
I was just looking for one of my codes to I'll just paste that here. So this could be this one use case which I have. So this get time of day has, I think, a good resolution, at least microseconds, if not nanoseconds.
Okay. Yeah, I think also as the problem size, whatever you're trying to solve, as it becomes large, probably this millisecond resolution might be sufficient actually. Because when things run over few months, it doesn't really matter.
Yeah.
Okay, so it seems like get time of day seems to be a good solution for this.
I have a question on copy private.
Copy
So,
private, okay.
if we have, so the broadcasting only happens after all the threads have passed the single directive, right? Single copy OMP and single copy private. That is the end of the single directive.
Right, and once all the threads have reached, yeah.
So if some threads are still before the single directive, and let's say the copy private variable is A, and if some threads are still using the value of A before the single directive, and if the value is then broadcast, then it would be wrong to update the value while the other threads are still using the value, right?
Yeah. But I'm just wondering, if that is the case, then you have to have a barrier, isn't it? If an implicit one is not there, then you have to put an explicit barrier.
Yeah. No. So let's say like we have 10 threads, and the fifth thread, for example, reaches the single statement first. And
Okay.
but all the other threads are still before that single block. And inside the single block, we're actually reading a value from a file, right? That's the example that you gave in the lecture. So
Right.
the the broadcasted value, now the fifth thread is going to broadcast this value of A to all the other threads. And these are actually using some value of A before the single block. So won't that be affected? I mean, won't the value of A in the threads before be affected, or will the broadcasting happen only when all the threads have actually passed the single block?
Yeah, whatever you said, the last statement is correct.
Okay.
Yeah, because I mean that is what is the internet behavior. Essentially it will only when all threads have arrived at that location at that and single, then only they will it will update, right?
Yeah. Right.
Yeah.
Sir,
Yeah.
while using ThreadPrivate, is it necessary to declare the variable as static or something? Because when I tried to run a code, it said that automatic variable cannot be ThreadPrivate, and when I did static.
Yeah, that's because so essentially if you have a dynamic array, is it? That's what you're saying, dynamically allocated array, right?
No, I'm just this is a variable, no, not an array, just a single.
You just have a static value. If it is the thing is, it has to know what is the dimension of the variable that you are trying to allocate.
No, sir. I mean, I'm just giving a single int A is equal to 10, just like that. Just a single variable, not an array.
Okay.
And after that, I declare, I give hash Pragma MP thread private of A.
Okay.
And so if this is the code, then when I try to compile it, it says that the automatic variable cannot be thread private. And this goes away if I give static int A is equal to 10. So that's what I'm trying to ask.
I don't think so. I think I have even tried for automatic as well. I don't know why it is saying this thing. Do you have any other A somewhere else? Or
no, it's a very small code. I just wrote a test code or something. And
I don't think it should be a static variable as such. Only thing is that you should be able to. I mean, if it is, it should be declared here, and then it should be again declared here. In the thread private, so that it will basically make multiple copies of this A for each of the threads. That is the intended behavior. In C, I think it should work even without static clause, I guess, because in Fortran you just have a common block, and then you would declare the common block data to be there. What if you declare this? If you make it a global variable, I think it will work again, because it will be it will have a file-wide scope. Is it?
yeah, I think it works if it's a global variable also.
Global it will work. So similar to the common blocks. Okay, well then maybe there is some restriction. I'm probably not aware of that.
Okay, so sure.
Yeah, I don't know. Maybe if Rupesh, do you want to add something here in case if I'm missing something?
Yeah, I am also not aware of this restriction, but I was just Googling right now.
Yeah.
And it looks like there is some sentence mentioned on openmp.org. So I'll just paste that in the chat box.
Yeah.
Says that variable that is part of another variable cannot appear in a thread private class unless it's a static data member of a C++ class. So I don't know if it has any meaning in this context, but yeah, I'm not aware of this particular issue. Yeah, global should work. Yeah,
Global should work. Yeah. I mean, in fact, you will be able to even allocate the variables dynamically also. Once you declare as a pointer and allocate data, that also works with ThreadPrivate clauses. I have used similar things before. Yeah. Okay. Yeah, maybe I'll also check this and get back in case if I find something on the static thingy.
Sir, I have one more question.
Yeah. Oh, yeah. Sorry. Oh, just hold on, please. Yeah, I think what what you said, I think the static one probably makes sense, unless because probably the scope has to be file-weight scope. Essentially, once you declare as thread private, they will probably last for the entire program. Maybe that's why it is requiring that. Yeah. Okay. I'll check that and get back. Okay. Please go ahead.
Yeah, sure. That makes sense. Anyway, so this one is about the wall time. When we write OMP get wall time,
Yeah.
we say that the function returns the per thread time, right? So so if we have to calculate the entire time taken, we'll have to run a critical statement, isn't it? If we have to add everything together.
So, sorry, can you please repeat?
If we had to calculate the whole time taken by the parallel block, since the WallTime function returns per thread basis, will it?
Yeah.
Will we need to run a critical statement in order to get the correct time?
No, the WallTime is basically per thread. This is the per thread time. So essentially, you need to have probably a private variable so that you will get the time in each of the threads as such.
Right. Okay.
Right. If you I don't think you will use a critical statement. You can just call W time, but only thing is that this time, whatever you are trying to calculate in the return statement, this has to be it has to be only a private variable so that you will get it for one thread when you subtract, because this is a per thread time, and for every thread you will get that delta t, whatever is the time difference.
Okay. Okay.
Yeah, if you want, you can kind of sum them for all the threads to get essentially the total time spent by all the threads.
Okay.
Yeah, but it is not because there is no summation as such. So there is no reduction or there is no mutually exclusive access is not required, because these will run on all the threads. But what you can probably do is, if you want only on a particular thread, then you can single it out in one particular thread. You can call it only on that thread. That is possible, right?
Yes, sir.
Yeah.
Sir, I have a question regarding in the problem of convolution, there are two for loops, and I have stated that parallel for first as 4, and then the second for loop also has 4, but it is stating in some Stack Overflow that it is better to use only for block with all the 8 threads to the first for, rather than dividing first this threads among the two blocks. So
I did not get the question. Can you please repeat it again? So you say you have a nested parallel for, is it?
yes, sir. And the first for I have provided 4 threads, and the next for also I have provided 4. But it is stating that it is better to use all the 8 threads for the first for, and and place y as parallel as a private variable. So which one will be more of? I mean,
no, I think if it is it giving like a kind of warning or something?
no warning, but I have not done the profiling, but it is showing more optimization in when I am placing all the 8 threads in the.
Okay.
In the case of first for me.
So who is giving you this? Who is telling you that it will be better, if you do it with 8 threads? Is it the compiler or something else, or the profiling tool?
It's online, just Stack.
Online. I don't know. Which online? I'm not getting the question. That's why. So
Stack Overflow. Somebody was suggesting that.
Oh, okay.
Instead of nested for loop, you could possibly use the inner threads combined with the outer threads. I think Krishna is mentioning not 8, maybe in this case 16.
16, yeah. Yeah, or else that kind of depends on the problem you're trying to solve. It depends on how much work is being done here and here, and the kind of dependencies you have. That it kind of depends on that. In some situations, maybe whatever is suggested is correct. Using the outer loop for all the 8 threads or 16 threads is better. Because I mean, of course, I think you understand that there is some overhead in creating these threads from the existing threads here, isn't it? Probably that is the reason they are suggesting it, that you use it, all the threads above. Maybe instead of going by whatever the comments that are made in that forum, what we can probably do is this tutorial 4 provides a good opportunity to test this dependency for which problems. Can somebody tell me for which problems you can test this? For both the first and 2 problems, right? Both of them have 3 for loops. You can try, whether this is better or the other one is better. At least if you take the matrix multiplication, you can have, because there is no dependency, you can have both I and j loops as separate nested ones, or you can have it one outside as well, right? So that probably you can test it for yourself and see as you change your number of the size of the matrix, you can see probably which one is better. You have to kind of play with it to get the correct kind of behavior.
Sir, it depends upon the data that we are allocating to each thread. So that can be one.
Yeah, that is also, yes. I mean, essentially, it depends on, when you say data, you are essentially talking about what is the workload that is you are giving to the threads, right?
Sir, another question in this case of 4 and 4, there are only 8 threads, right? There are not more than 8.
16.
16.
Yeah.
Okay.
Yeah. Because each one of here will four more threads when they reach this statement.
Okay.
Yeah.
So about that same question, can you say how this forking happens if the number of threads is like we have 8 threads, we are using the case just you said, so we need 16, right?
Yeah.
Yeah, so we have only 8 and we have used that statement. So how will the forking happen? Will it wait for the other threads to finish and then fork it out?
Okay, so what you're saying is that no, I don't. It will be yeah. I mean, essentially, it will be like kind of hyper-threading, right? Because you might have set this 8 using your environment variable, right? To be OMP num threads as 8, but then when so it's going to, and your machine might only have, let's say, maybe 4 cores or something like that, or maybe 8 threads.
Yeah.
Then it will be it will be kind of performance penalty. You're right.
Okay, so in that case, it will get delayed because of that. It will wait for the other threads to finish, then assign.
Yeah, exactly. I mean, that will be like kind of, it'll definitely spawn more threads, which are kind of hyper threads, but the problem is that these hyper threads kind of appear to be, let's say, independent threads, but they're actually can only begin once the other, the master thread kind of thing where, on which they are dependent on to finish. So, so you remember, I think one of the problems we did probably a couple of weeks back, that was the calculation of, I think when we were discussing about the reduction operator or something, we had this, 0, 0, or when we did the Fibonacci series, right? So we had several zeros coming up instead of, the correct values. And the number of zeros we were getting were different because of, depending on the number of threads I was using, right? That's precisely because of some threads are, kind of virtual. So, yeah, I don't know if you remember that example. I kind of did it a few times, yeah.
Yeah, I get the ideas.
One question from Venu here. Is there any way to stop a variable from being thread private later in the program? What do you mean by thread private? You declare, essentially when you declare the variable itself, right? So you want to make it, you want to remove the variable, is it, from the thread private? Yeah, I don't know. I don't think you probably can remove it. I'm not sure, maybe. Using pointers and malloc, yeah, I don't have a C code as such. I remember working with that in Fortran before. How to search for the code. Maybe you can easily write that. Okay. And then there was one question I think in the lecture I posed. I don't know if I answered. A kind of follow up of what Venu asked. So how much do you allocate for the thread private? Let's say you have an array. Would you allocate an array of length n? Would you allocate n or n by p for each of the threads? Or does it depend on the application you're working with? Maybe I can pose this question again. Let's say if you have to use malloc, how would you do it? Let's say you have declared something as using thread private. Let's not worry about whether it will work or not. What would be the approach you would take? Can someone comment on that? So I have declared using a thread private pointer or something. I want to allocate. What will be that statement that you would use to allocate, or where would you allocate rather? I think I have given out the answer. So essentially, we have, if you are allocating for a serial program, you just have a malloc or malloc or whatever. Now, if you have to do it for all the threads, where would you allocate it?
So outside the parallel region?
No, if it is outside, it should be inside, right? Outside or inside? The thread private will certainly appear outside, but what about the allocation part? Inside, no? Because the malloc is like a function call and that has to be seen by all the threads. I believe it's kind of inside. Maybe you can test it. I think that answers Venu's question as well. So it will be straightforward. I don't know if it will work or not. You have to test it. One question, another question I have is this. So we will be dealing with this finite differences. Yeah, that's right. Yeah, essentially you have a file scope pointer. Yeah, thread private, and then allocate it. Yeah, exactly. So that way, I hope that is the flow. Okay. Yeah. So when we'll be dealing with these finite differences, in the next lectures we'll be looking at the implicit finite differences. And then we will go on to solution of partial differential equations and system of linear equations. Okay, essentially Ax equal to B type problems. Those are all all these things are all of you can easily follow, right? In case if you have difficulty, let us know. We can maybe point you to some books or something. Okay, you can refer. I hope these things are taught to you in some of the earlier courses.
Sir, I have a doubt in the last question of the tutorial 4.
Yeah.
So is the boundary condition at the end is given there, sir? Is it fixed?
Boundary condition. So your u of x is given at all the points, including the boundaries.
Okay, so to evaluate the point outside the boundary, how means we need actually that.
Yeah. So what I'm saying is that don't let's say if you have a second order scheme, if you have to calculate I derivative of I here du dx at I equal to, let's say, 0. What I'm saying is that use a forward difference. Even in the context of interior cells being evaluated using, let's say, second or fourth order accurate, use a forward difference or backward difference for the boundary and the near boundary points.
Okay. In that case, that would not be required. Okay.
Yeah, in that case, it will not be required. But another approach is that, as you mentioned, if you do not want to, so this is the correct approach. I mean, correct approach, this is kind of applicable when you deal with, some kind of discrete problems, because you will never know what is outside. It's kind of, outside the domain. So the downside of this is that your accuracy is going to be degraded because you're using a, second order scheme in the interior and a first order scheme at the here. So as a result, your accuracy of the entire scheme for the entire domain will be degraded, because of this first order. Now, let's say for a hypothetical case such as what is given in the problem, where there is a u of x is, some function, and then I also say that this is, you have to compute it over -1 to 1, but this function is also valid even outside. If I say that, then you can use whatever is the second or fourth order, but these ghosts or kind of virtual points, you can fill them using the same function. Okay, but it has to be given that this is valid even outside for the purpose of near boundary calculations. Does it make sense?
Yeah. Okay.
Okay. Yeah. Okay, I want to kind of still comment more. That kind of comes back to your question of what is the boundary condition here. Okay, so I didn't give a boundary condition, but another way is basically using this boundary condition, you can extrapolate and calculate what are these values outside as well. Okay, that is also possible. From the, so let's say this is the boundary, I give you some boundary condition, then these are the interior points. Then from the boundary condition, you can kind of extrapolate and calculate what are these values, and then once you have these values, you can continue to use the higher order scheme, second order, fourth order, whatever, and then that is also possible to compute. Okay, that is another one. So actually, we discussed 3 different methods. Okay, all you will find all 3 to be existent in when you start doing numerical analysis.
Yeah. Thank you, sir.
No problem.
So, Kameshwar, this last scheme that you mentioned will have the best precision, is that?
Exactly, because this will be kind of it is using the same same scheme everywhere.
I see. Okay.
Yeah.
Thanks.
But only thing is that when you extrapolate it, this extrapolation has to be also of the same order as what is the interior scheme. Now that will bring in some complexity, but that is okay. Yeah.
I see.
Yeah, right. I think that's a very valid question. The third one is the will maintain the order of accuracy in a better way.
Sir, I have a question. Can we use copy private other than single? I mean, other than with single?
I don't think so. Copy private is kind of tied to the use with single only, I guess. Because from this what is the function of what copy private does, it makes sense only to copy from essentially replicate what is there on one thread to all other threads, or kind of broadcast.
Yeah, but like I was thinking of a scenario where let's say we have a critical section, and what one thread does in a critical section, it wants to broadcast to other thread before other thread enters into the critical section. In that case, we might be interested in copying the private value of a thread which is currently in the critical section to someone who will enter next to the critical section.
Yeah. Okay. So that is, I don't know if such a such a thing is allowed by OpenMP easily. See, if you work with, let's say, P threads or so POSIX threads, these kind of behavior can be done. You have to write a lot of code, but it can be done. Because by critical we mean that we don't have. See, why I'm saying is that by critical we say that the threads will be given access one after the other, but we cannot really compare find the order in which they would be getting that. okay, maybe you can say, okay, inside the critical, I will use the thread my rank and then get it. But I think probably we will end up with a, a kind of a no exit point, maybe. I don't know.
Okay. Yeah.
I have to a little bit see if that is possible.
Yeah, probably I'll check this thing.
So in the critical section, you want to check whether if a particular thread comes, then you want to broadcast it to others, is it?
Yeah. Like in many cases, this might be useful, right? Like
Yeah. If that is the case, then you have to give away your critical section. You have to write a kind of a false critical section. You basically put a loop where your threads will go one after the other, and then do that, because you don't want to combine critical with broadcast.
Yeah. I mean, so you are trying to say that we'll completely remove the critical section.
Yeah, I think so. And then you kind of probably have a loop, and in which you enter, and then you find out, and then you broadcast. Something like that has to be done, maybe. I don't know, because using critical something else might make it a no exit point.
Yeah. I mean, like my point was like you have a critical section. I mean, you have a part of code where you want the computation to be done by one thread only. Let's say you are. Let's say computation is like we're updating a shared variable or something, but by the end you update the shared variable. After that, you want to be seen by. I mean, you are taking that shared thing into private, and you might want it to broadcast it to everyone. Something like that, I was thinking.
Yeah. I mean, certainly, definitely, we'll probably encounter such scenarios. If that is the case, I think we have to think of probably rewriting it rather than using copy private. I mean, I don't think you can use copy private with critical. Yeah, but this combination may not be a good idea, I guess.
Yeah, probably it might.
Yeah, someone. Yeah. Yeah, but being very open and being kind of high level, it will still provide these kind of behaviors. You can find out by kind of looking at the functions you have and the exact behavior you want your threads to be, but it may not provide a very low level control like what POSIX threads provides. Yeah, that will also come at a cost that you have to write a lot of code.
Yeah. Okay. Yeah. Thanks.
But if you can please post, let's say your idea, maybe I'm sure you'll get we'll get a lot of ideas to reply to your question.
Yeah. Okay.
It'll be good in the discussion forum. Let's say exactly what you want to, your code to do, and then I'm sure very easily we can find some solution.
Yeah. Okay, I'll post that.
Yeah. Thank you. Other questions? Anybody?
Sir, one question regarding the difference between single and master director.
Yeah.
So for single, we have to explicitly specify no wait if we do not want the other threads to wait for the single thread to finish, right? But for master, it's by default no wait, right?
Right.
Okay, so if we fine. So for master, we don't have to specify the no wait.
Yeah, I think as soon as it is done, I mean, essentially, master is doing, the threads will race ahead.
Okay, but what if we want it to be the other way in master? Like,
Oh, you want the threads to wait here?
yeah.
You can put a barrier, I think, outside the master.
Okay.
Yeah, they'll just wait here for master to come.
Okay.
Yeah, that sounds nice, no? All the other threads will wait for the master to arrive.
Yeah.
Yeah, these are all, what I mean to say is you may get these behaviors, but in when you work with, unless you're working with a very, depending on the code, you may not get into so many varieties of, let's say, thread behaviors. Probably there are certain thread behaviors, once you figure out, you'll be using them in most part of the code that you probably will be working with. Unless it is, depending on the application, I'm not sure, maybe, yeah.
Yeah, I have a question about using parallel for separate from parallel. Like we had in the odd even transposition sort.
Yeah.
You have two loops, right? You have outer and inner loop, and
Right.
before the outer loop, you had Pragma parallel.
Right.
You had Pragma OMP parallel, and after that, you had a Pragma OMP for.
Yeah.
Yeah. So when we say Pragma OMP parallel, the forking happens, right?
Yes.
So
Yes.
and then you're starting with phase equal to 0, which means each thread is going to start with phase equal to 0.
Yeah. Yeah.
Is
right.
that what?
That's right. Yeah.
So
that's
which
right.
means if we have an array of size 10, then each thread will execute that array 10 times. Each thread will iterate from phase 0 to phase 10. That's
Yeah.
what.
Yeah. Right. True. Essentially, you have a private variable for phase.
Okay. So, but that would mean that you're sorting the array 10 times, right? I mean, see, if you run the serial code, then you'll just have to go from phase 0 to phase 10 just once.
Yeah. But the thing is, this part of the code which is done is anyway done by all the threads, so it would not add up to a lot of time. Only thing is that all of them are doing the same thing, but that's not much compared to what your the work sharing that is happening inside.
Okay. Okay.
Yeah, that is true. You're very right. Essentially, your let's say your serial code is taking some t seconds. Your parallel threads, all of them are also taking t seconds together.
Yeah.
Yeah, but you're right. That's kind of the little bit of overhead there. It is kind of probably implied that forking takes probably more time than doing this particular task. That's why we are trying to do it this way. Depending on the
Yeah, and the objective was to just reduce the overhead time. That's why we had these two separate
Right.
parallel blocks. But I think one disadvantage of that is that the loop itself might get executed 100 times instead of just 10 times, the outer loop.
That is true.
Each
that is
thread
true.
will execute it 10 times, right? So
yeah, I mean, whatever is n, that the same loop will be executed by all of them. Essentially, all of them will execute the same loop because there is an implied barrier at the second for loop and the first for loops. So they will not progress after once the other threads are all finished. Yeah, that is true.
Okay.
But I mean, that is kind of I don't know. I mean, depending on the behavior, that's kind of unavoidable because all of them actually have to have the the particular phase. You somehow have to communicate it to them anyway, right?
Yeah.
So I also had a question on the same topic. You said that the hashtag Pragma for will be using the threads that were already created outside, right?
Yeah.
So, I mean, could you draw a diagram and show what is actually happening? Because, I mean, isn't the other thread already occupied with some other work?
No, see, the thing is, you have basically look at this thing, work sharing, and then directive, right? And then you have basically doing the same work. Let me put this word, okay? So work sharing is basically when you say, let's say you say parallel and just leave it, okay? You basically write hash pragma OMP parallel and just leave it, then whatever you have here will be executed by all the threads, right?
Yes, sir.
Yeah, you have forking happening, but all of them will do whatever you have given here. All the instructions will be done by all of them. That may not be of any use unless you do something else like what we have calculated in the integration of the example, right? Now, when you say hash pragma OMP parallel for, then these threads are going to divide the work. Basically, they are going to share the work. So let's say if this goes to up to some 100 iterations, then all the 4 threads are going to take, each of them is going to take 25 of them approximately, let's say.
I understood that, but then what do you mean by just for without the parallel? Hashtag Pragma OMP for.
Because the parallel, this hash Pragma OMP parallel already has some threads. There are 4 threads already available. Now, the 4 threads are doing as he said, they are already executing the phase. So they first did one line where their phase equal to 0, they enter. Now, when they come here, hash Pragma OMP for, now these 4 threads will divide this, whatever is the number of points, iterations you have, 100 into 4. And let's say thread 0 will get 25, thread 1 will 25, and so on. But if you had written another parallel here, then these 4 threads will fork into another 4 threads. And only these inner 4 threads will be dividing this thing, whereas the outer ones are all waiting. Does it make sense?
No, I mean, what I'm not able to visualize is that you are using the threads which are already forked. So, I mean, when one thread is assigning work to another thread, what if the other thread is already occupied?
They are not. Okay, hold on. I'll just explain you here. So you basically have hash pragma OMP, whatever, you just have parallel here, okay? We have forked into some 4 threads, right? And then you enter this thing, hash pragma OMP, you just say OMP for here, right? Now they are not occupied. Actually, once they come here, they will all come to the statement, and then they will divide the work here, right? The master is going to help the other threads, and then you have work sharing happening here, right?
So all the threads will wait until they're all done before the for is executed, is it?
No, essentially, yeah, because so I mean, wait in a sense, you basically have all the threads whenever they come here, they will get that piece of work that needs to be executed, right? So essentially, the threads will divide the work among themselves once they see this statement for. If they don't see this for, all the threads will execute. Just like they are executing the phase for all the n iterations, all of them will again execute this m number of iterations. All of them will execute, which is not what we want, right?
So is it like there's a barrier that will that all of them will have to finish their work before they start reassigning the work, or?
I don't say it is kind of a barrier. It doesn't have to be a barrier as such, because the master thread, once it comes here, it's going to do and divide and kind of provide the work for all the threads. So it may not be a barrier. I don't know. It may not be a barrier here, because it's the I mean, one thing to note is that there are actually no lines in between here unless the outside for loop. Even if you had, they will execute, and then once they come here, they will pick up their own piece of work because of the OMP for. I don't know if I can call it a barrier at this thing, because we are not forking here.
Okay, got it.
Right, so they will just execute. They'll keep executing. Somehow the master thread or that thread will get what is the iterations it has to do. What is the share it has to do out of this for loop. Does it make sense?
Yeah, I think it's understandable. The parallel is just for forking, and the for is for dividing the work. So
yeah,
when they reach the for, when they reach the for statement, they all, I mean, we don't know if there's a barrier or not, but what we know is that it cannot, the forked threads cannot fork a second time, right? So unless you've turned on that nested forking.
Nested forking and a parallel here again.
Yeah, exactly. So it's just with the remaining threads itself, it will divide the work. So if there's 4 threads, it will divide the loop into 4 parts.
Yeah.
So I have a doubt.
Yeah.
Yeah. So we usually define this int thread count equal to 1 and thread count equal to strtol. In all these things we do in our main function.
Yeah.
So like how will we call this hash pragma omp parallel statement inside like some other function, because that function uses the variable thread count. I mean, how do we do that?
No, essentially, the thread count that you have is
Its scope is limited to main function only, no sir?
no, but that's why I think we are passing it down there, isn't it? I think in the can you refer to so there are two ways of implementing this thing. Either you can call this again in the local function. You can just again call what is the OMP get num threads, and it will give you what is the thread count.
Okay.
Right? Or else you can make this as a global scope variable, because this can be shared. Whatever you are caching, that can be shared, or you can call the function again, right?
Okay. And also like the thread count is just a simple variable that we are defining and we are giving it a particular value.
Number,
So
yeah.
how does the OpenMP knows that the value in the thread count is the like total number of threads that we have to use?
No, it doesn't know. It only knows that when you say num threads and some number, so this number we are calling in a thread count. You can as well give just 4 here. Then OpenMP would basically make a parallel region here with 4 threads. So you can, I think we discussed this in the last, few lectures before, probably in the, last lecture, where you can give whatever you want, 4, 8, 10, whatever, So this will take a precedence over the environment variable that you have set in the shell. And this cannot be arbitrarily large, okay? So, but OpenMP will try to give whatever is requested here. But there are some restrictions on, let's say if you just put some 10 power 5 or something, it may not give you that number.
Okay, and like suppose I have like put here num threads in bracket, I put 4.
Yeah.
And I have a thread count sub variable also in main function which has value. Suppose it has a value 8. Okay, and I have a function outside. I have defined a function outside to which I am writing int thread count equal to OMP get num threads function. So what value will that thread count variable get? Will it get 4 or 8?
That depends on what you pass in the executable. No, if you say dot out and you have passed 8, then the thread count will get 8.
No, I mean so suppose like I have passed value 8 here.
Yeah.
So my thread count inside the main function has like value 8 currently. It's like currently just a variable. It has nothing to like. It has got nothing to do with the number of threads or anything. And then I call the statement hash pragma omp parallel num threads, and in bracket I specifically write 4.
Yeah.
And after that I am calling a particular function.
Okay.
Inside that function definition, which has been defined outside, I write like again a variable. Suppose int a equal to omp get num threads. So what value will a have? Will it have the value which I wrote in my shell, or will it have value 4 which I gave inside num threads?
Here, if you are calling this inside this parallel, if you call OMP get num threads, it's going to give you 4.
Oh, okay, sir. Okay.
Right?
Yeah. Okay.
Because as far as the program is concerned, this is it has no relevance to this because you have given 4 here.
Okay, sir.
Yeah. So this is the behavior even if you have set, let's say, even if you did not pass 8, rather you had set your OMP, set num threads, so the OMP num threads environment variable. Even if you have set this to 8 and ran the program, even then if you have explicitly specified as 4 here, this A will get only 4, right?
Yeah, and like if I have to call this hash pragma omp parallel num threads in bracket 4 inside some other function, then like I'll have to define this thread count as global variable.
Yeah, you can define global or you can even define local also. That doesn't matter.
No, if I like define it inside the main function, if I define like int thread count is equal to like whatever we do in main function, and in some other function I write hash pragma omp parallel num threads in bracket thread count, then like thread count doesn't have scope outside main function, then it will start showing me error.
Yeah. I mean, either you can make thread count another local variable inside the function, or you have to pass it from through the function arguments, right?
Yeah. Okay.
Yeah. So I think it really, I mean, that behavior you can control depending on what you want. For example, we have used both notations. Sometimes we have defined thread count in the main function, and then sometimes we have defined inside the trapezoidal rule whatever we have done. So that also is there. But I think thread count is of is of not too much of relevance. I think the more important one which you are not thinking about is the my rank. So what should my rank be? Instead of the thread count, instead of this one, what will be the thread num? The OMP get thread num. This my rank, this should be private. You have to make sure that is happening. Okay, this should not be shared. That is more important, because if you make it shared, there'll be a big mix-up, isn't it?
Yeah. Yes.
Yeah. So either you define this, because if you define this thing before your parallel region, your my rank will be shared, because by the time parallel region comes, whatever is the variables, it will make it shared. Then you can test the behavior. You will get very different answers. So this either you have to define inside your parallel block so that it will be a private, or you have to say explicitly that this is basically a private variable using the private class.
Yeah. Okay, sir.
Yeah, all these things you can easily test. Just a couple of lines of code, you can easily test the behavior, whatever we discussed. It will be much more complete if you can do that. Okay.
Yeah. Yes, sir.
Yeah. Okay. Any other questions, anybody?
Sir, just for the clarification, there was no parallel programming involved in the tutorial 1.
Tutorial 1, no parallel programming. That was basically just a introduction.
Basics of C.
Started C or Fortran, whatever you wanted to do.
Okay.
Yeah.
Okay.
Yeah.
Thank you, sir.
Yeah, no problem. Any other questions? Anybody?
Sir, in the case of odd even transposition, you have used a function called swap. Sir, is it a valid way to write? Because then if you write it function outside that parallel block, will that temporary function will be that int temp will be a private copy to each thread? Or
Yeah, I mean swap is, yeah. So say it again. Is it a valid way to?
Sir, is it a valid way to write? Because the int temp, there is if I write a function outside if I declare somewhere and write int temp and then store that value to swap, then will that temp value will be private to each thread, or?
Yeah, it will be private, no? Whatever you declare inside the parallel block are always private, right?
So, but this function is, I have made it a different declaration. I mean, it is in the, in the declaration, I have written it outside, and just I'm calling swap address of a of I, comma a of I plus 1.
Yeah, so this is being called from a parallel block, right?
Yes, this is in the
then it will be private, right? Then all the variables declared inside the function will be private.
Okay.
Yeah. In fact, you don't need a function. I just used it. You don't need a function. You can probably just write a macro or a one-line macro. That will save the overhead of calling the function and return the function.
Okay.
Yeah. Any other questions, anybody? Okay, no problem. Thank you, Rupesh. All right, if there are no questions, I will, okay, so there is one more question. I think class last private has to be used in every OMP for all sections. We can't use last private once and expect it to stay. Yeah, that is true. Yeah, all these classes are specific to the particular parallel block we are addressing, isn't it? So it has to be wherever you want it, it has to be repeated. Because so you have to repeat it every time you do it. So for all the for loops or all the sections or something like that, right? Okay. Well, if there are there any other questions, students? Okay. Yeah. If there are no more questions, let us call it a day. Okay. Have a good weekend. I'll post this recording. I think you'll also get a link on the Moodle. We will change gears and then work with implicit finite differences, and we'll go a little deep into the numerical methods in the coming week. Okay. All right. Thank you. Bye-bye.